Hey, Honors Physics students, here are some hints about the textbook assignment for Chapter 10 and 11. Remember, this won't be all the problems, but hopefully it'll give you a good sampling and a way to start on almost the whole textbook assignment. Remember, my advice would be to work on a problem, pause that problem on the video, and then work it through, and then go to the next one. That'll give you the best option. There are so many problems that I will do this very briefly, but hopefully you'll get a start on them that way. So let's start by looking at number 52. For number 52, you'll use the formula work equals force times distance. Remember, the force, when you lift something, the force is the force of gravity, which we already know is the same as the weight, m times g. On number 55, you're also going to use work equals force times distance. There you go, common theme. Problem number 59. Recall, the power is the energy divided by the time. And remember, work and energy are the same thing. So if you find the work done, that's the same as the energy for the power formula. That's number 59. Well, let's jump ahead to number 61. For number 61, again, we're going to use work equals force times distance. But for the force, we can't use the full force. We have to multiply it by the cosine of the angle to get the horizontal force. That horizontal force is what you use in the work equals force times distance. For number 62, again, you see so many of these problems use work equals force times distance. Again, because you're not applying the force in the correct direction, we're going to use work equals force times cosine theta times distance. This time, we don't know what theta is, but it's just algebra. If we know every other part, the work, the force, the distance, we can solve for theta. Remember, inverse cosine is very useful for that. And number 64. Making a diagram is so very important for almost every problem that, that involves strange pictures. On this one, what we've got is a distance that we don't know. That's very useful to find out. So you might start with using trigonometry. The sine of 30 degrees, remember sine of an angle is the opposite divided by the hypotenuse. The sine of 30 degrees is equal to the opposite 1.15 divided by the distance. So by doing the old switcheroo, we can find out the distance. When you apply work equals force times distance, because the force is in that same direction, we can use the entire force times distance, and work equals force times distance. Number 69 is a slightly different kind of problem. For part B, you are given a graph and they ask for the work. Remember, the work is the area under the graph of force times distance. For number 71, there are a couple of ways to approach it. You could use power equals energy divided by time, or a very fast method is power equals the force you apply times the velocity you give it. And that's number 71. And one more problem to show you about Chapter 10 before we go to Chapter 11 is number 91. For Part A, again, this is one of these problems where a diagram is useful. You are applying an unknown force. However, the useful force that's horizontal is 805 newtons. That is horizontal force. Well, I gave you a formula that horizontal force is equal to force times cosine theta. If the horizontal force is 805, you should be able to solve for the force and use that for the rest of the problem. So now we've finished Chapter 10. Let's jump ahead to Chapter 11, page 307 to 310, starting with number 55. The hint on number 55 to get you started is they give you kilometers per hour. Make it into meters per second. The rest of it should be easy to solve from there. For number 59, recall, work is force times distance. We got that from chapter 10. But what is new for chapter 11 is work is the same as the change of energy. And if all the energy that you change is kinetic, work is equal to the change in kinetic energy. That's how you do number 59. Number 60. First, suggestion. If they give you the weight in newtons, solve weight equals m times g for the mass. Because friction is a constant force, friction always obeys the formula work equals force times distance. Well, change of kinetic energy from the beginning to end is therefore equal to the work that friction does, and you should be able to solve, therefore, for the unknown. 62. Now we get to the place where gravitational potential energy is used, and that's equal to m, the mass, g, 9.8 meters per second squared, times the height. For 71, A and B should be quite reasonable. Part C, it will help for you to recall that the change of kinetic energy is equal to the work done. Don't forget, centimeters are not going to get you to the right answer. And the reason is because a joule is a Newton times a meter. The finish goes like this of chapter 11. Number 74. Conservation of energy means that the potential energy you start with, this gravity potential energy, is equal to the kinetic energy that you pick up later on, which is equal to 1/2 mv squared. We use that many times. For number 75a, recall, when you do work on something, it changes the energy. And if you change the kinetic energy, then all the force times distance applied is equal to the kinetic energy that you either gain or lose in a circumstance. But for part B, now the work you do, which you already figured out, is now turning into gravitational potential energy. That should help you on 75, part B. For 78, use the conservation of momentum that you learned in chapters 7 and 9. In number 8, suggestions. Start by using the weight equals mg formula to find the mass. Then what you have to realize is that the potential energy that you have at the top all turns to kinetic energy at the bottom, and there's only one unknown. Well, finally, one more problem to look at. That's not all the problems in the assignment, but here's another one. For number 85, potential energy, mgh, turns into kinetic energy at the bottom. All the kinetic energy disappears, and it disappears as work equals force times distance. So if you solve for the potential energy, that eventually could be equal to the force times distance, and you simply divide. That should help.